Okay, hey everyone. If you're here, and I hope you have already finished at least one version of this function. Okay, the function is we are gonna have receive a n by n matrix. So in this matrix will be the parameter of this function, and then we are gonna go through all the matrix or all the diagonal values, and we are going to find the largest diagonal value, and then we are going to return that. And well, let me show you the first solution. The first solution is, well, I'm assuming that the largest value before I start the iteration, it's going to be the index 0, 0, which is the upper left value. Okay, and then I'm going to get the n, which is the size of the matrix. So for this one, the size will be 2 because that is a 2 by 2 matrix. And after that, I'm going to do a iteration from the 0 to n minus 1. And if the matrix II is greater than the largest diagonal value, and then the new largest diagonal value will be the matrix II. Well, I'm using the II because the diagonal value will have the index 0, 0 or 1, 1 or 2, 2 or 2, 3, 3, 3. So anyhow, well, those two indexes are going to be the same, and eventually after we finish this iteration, we are going to return the largest, because after we go through all the diagonal values, and then I'm going to return the largest diagonal value. And if you look into this code, I only use one iteration, and that is the iteration iterate from 0 to n minus 1, so a total of n rounds, right? So this is a 1, this is a primitive step, this is a primitive step, and then we have this one, iterate for n rounds. And then we have this condition, and for this condition, remember when we are evaluating the worst case is this condition is true, because then we are going to have to run one more line of code. So if we want to count the number of the primitive steps, this should be in, this should be in, and this one should be in as well, because we are counting the worst case. So the worst case is the if condition is a true. Okay, and eventually we are going to do a return. So that is 1, 2, 3. So 3 plus 3n. And if you do the trick of going from the Tn to big O, and you will see that is a ON algorithm. And why this is the ON algorithm? Because even though we have a n by n matrix, I didn't visit all the n by n values. I only go through the diagonal values, because I'm using the matrix II here. That could be matrix 0, 0, 1, 1, 2, 2, 3, 3. Okay, so that is a ON algorithm I'm talking about. And here is another variant, and that is a ON square algorithm. So the idea is, in this case, I'm visiting all the values in this matrix from 0, 1, 0, 2, 0, 3, 0, 4. Those are the values not on the diagonal, but I'm visiting them anyhow. So I'm using for I in range n to using I as the first matrix, first index, and I'm using j as the second index. So if I and j are not the same, I do a continue saying, okay, that value I'm trying to visit, but I know that's not a diagonal value, so start over. And otherwise, well, if I and j are the same, and then I'm going to check if the matrix ij is greater than the largest. If it is, and then the largest will be updated to matrix I and j. Okay, so for this one, the coding is a little bit harder, because in this case, I'm visiting all the n square values in the n by n matrix. And for this one, if you want to see, this is iteration for n rounds, and this is another iteration for n rounds. What does this mean? This means that is a n iteration inside another n iteration. So we are going to iterate for a total of n square runs, and that makes this algorithm a quadratic algorithm, because that is a ON square algorithm. Okay, so for those two solutions, then you should be able to write those two algorithms, and those two algorithms are not so hard. That is a little bit harder than entry-level Python, but you should be able to code them. And number two, after you have those two algorithms, and you should also be able to evaluate the time complexity and come up with the big O. And the general process should be you write the code, and then based on the code you come up with the tn, and based on the tn, and then you move one step further, you get the big O, and then you will see this one is a ON algorithm and this one is a ON square algorithm. Okay, so anyhow, this is a quick sum up, and we are using the big O to measure how quickly the runtime grows when the input size increases. Okay, and here are some of the most common ones. O1 for constant, so that is a constant time algorithm, and ON linear time algorithm, and ON square the square time algorithm. And usually when we have the algorithm we want to evaluate, we started from the Tn, that is we want to count how many primitive steps are there when we run a input of the size n, and then we based on the Tn, we drop the constant, and then we drop the less significant parts and evaluate, and we consider the worst case, and eventually we are going to come up with the big O. Okay, so I will see you in the next video. Bye.